This video is created by Nihar from YouTube. This video is created by Nihar from YouTube. What is a magnet? A magnet is a material or object that produces a magnetic field. This magnetic field is invisible, but is responsible for the most notable property of a magnet, a force that pulls on other ferromagnetic materials, such as iron, steel, nickel, cobalt, etc. and attracts or repels other magnets. 1. Samarium Cobalt Magnets like NFEB magnets. SMCO magnets are also very strong and difficult to demagnetize. They are also highly oxidation resistant and temperature resistant, withstanding temperatures up to 300 degrees Celsius. Two different groups of SMCO magnets exist, divided based on their product energy range. The first series, SM1Z05, has an energy product range of 15 to 22 mgo. The second series, SM2CO17, has a range that falls between 22 and 30 mgo. However, they can be expensive and have low mechanical strength. 2. Neodymium iron boron NFEB magnets. This type of magnet is composed of rare earth magnetic material and has a high coercive force. They have an extremely high energy product range, up to 50 mgo. Because of this high product energy level, they can usually be manufactured to be small and compact in size. However, NFEB magnets have low mechanical strength, tend to be brittle, and low corrosion resistance if left uncoated. If treated with gold, iron, or nickel plating, they can be used in many applications. They are very strong magnets and are difficult to demagnetize. 3. Electromagnetism. Electromagnetism is a branch of physics involving the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles. The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic fields, and it is responsible for electromagnetic radiation such as light. It is one of the four fundamental interactions, commonly called forces, in nature, together with the strong interaction, the weak interaction, and gravitation. 1. At high energy, the weak force and electromagnetic force are unified as a single electroweak force. Lightning is an electrostatic discharge that travels between two charged regions. Electromagnetic phenomena are defined in terms of the electromagnetic force, sometimes called the Lorentz force, which includes both electricity and magnetism as different manifestations of the same phenomenon. The electromagnetic force plays a major role in determining the internal properties of most objects encountered in daily life. The electromagnetic attraction between atomic nuclei and their orbital electrons holds atoms together. Electromagnetic forces are responsible for the chemical bonds between atoms which create molecules and intermolecular forces. The electromagnetic force governs all chemical processes which arise from interactions between the electrons of neighboring atoms. Electromagnetism is very widely used in modern technology, and electromagnetic theory is the basis of electric power engineering and electronics, including digital technology. There are numerous mathematical descriptions of the electromagnetic field. Most prominently, Maxwell's equations describe how electric and magnetic fields are generated and altered by each other, and by charges and currents. Theoretical implications of electromagnetism, particularly the establishment of the speed of light based on properties of the medium of propagation, permeability and permittivity, led to the development of special relativity by Albert Einstein in 1905. 4. Alnico magnets get their name from the first two letters of each of three main ingredients, aluminum, nickel, and cobalt. Although they feature good temperature resistance, they can easily be demagnetized and are sometimes replaced by ceramic and rare earth magnets in certain applications. They can be produced by either sintering or casting, with each process yielding different magnet characteristics. Sintering produces enhanced mechanical traits. Casting results in higher energy products and enables the magnets to achieve more complicated design features. 5. An electromagnet is a kind of magnet where the magnetic field is created by an electric current. The uses of electromagnets are given here to help learners understand the topic more effectively. Electromagnets can be considered as a temporary magnet that functions with the help of an electric current. The magnetic strength of an electromagnet can be easily altered by varying the amount of electric current, and its polarity can be changed by varying the direction of the electric current. Electromagnets are used for various purposes on a day-to-day basis. For example, electromagnets are used in large cranes which are used in waste yards. Electromagnets are also widely used in numerous electromechanical and electronic devices. Some common uses are given below. 10 Uses of electromagnets: generators, motors, and transformers, electric buzzers and bell-shaped phones and loudspeakers, relays and valves, data storage devices like VCRs, tape recorders, hard disks, induction cooker, magnetic locks, MRI machines, particle accelerators, mass spectrometers. 6. Ferrite magnet. A stack of ferrite magnets. A ferrite is a ceramic material made by mixing and firing large proportions of iron oxide, Fe2O3, rust, blended with small proportions of one or more additional metallic elements, such as strontium, barium, manganese, nickel, and zinc. 1. They are ferrimagnetic, meaning they can be magnetized or attracted to a magnet. Unlike other ferromagnetic materials, most ferrites are not electrically conductive, making them useful in applications like magnetic cores for transformers to suppress eddy currents. 2. Ferrites can be divided into two families based on their resistance to being demagnetized. Magnetic coercivity. Hard ferrites have high coercivity, so are difficult to demagnetize. They are used to make permanent magnets for applications such as refrigerator magnets, loudspeakers, and small electric motors. Soft ferrites have low coercivity, so they easily change their magnetization and act as conductors of magnetic fields. They are used in the electronics industry to make efficient magnetic cores called ferrite cores for high-frequency inductors, transformers and antennas, and in various microwave components. Ferrite compounds are extremely low cost, being made of mostly iron oxide, and have excellent corrosion resistance. Yugoro Kato and Takeshi Takei of the Tokyo Institute of Technology synthesized the first ferrite compounds in 1930. 7. Rare earth magnets are strong permanent magnets made from alloys of rare earth elements. Developed in the 1970s and 1980s, rare earth magnets are the strongest type of permanent magnets made, producing significantly stronger magnetic fields than other types, such as Ferrite or Alnico magnets. The magnetic field typically produced by rare earth magnets can exceed 1.4 teslas, whereas ferrite or ceramic magnets typically exhibit fields of 0.5 to 1 tesla. There are two types: Neodymium magnets and Samarium Cobalt Magnets. Rare earth magnets are extremely brittle and also vulnerable to corrosion, so they are usually plated or coated to protect them from breaking, chipping, or crumbling into powder. The development of rare earth magnets began around 1966, when K.J. Stronat and G. Hoffer of the U.S. Air Force Materials Laboratory discovered that an alloy of yttrium and cobalt, YCO5, had by far the largest magnetic anisotropy constant of any material then known. 1. The term rare earth can be misleading, as some of these metals can be E3-4 as abundant in the Earth's crust as tin or lead 5, but rare earth ores do not exist in seams, like coal or copper, so in any given cubic kilometer of crust, they are rare. The major source is currently China. 6. Some countries classify rare earth metals as strategically important. 7. And recent Chinese export restrictions on these materials have led some to initiate research programs to develop strong magnets that do not require rare earth metals.